So as we continue our discussion of graphs, we are going to look at one more popular algorithm that is used for searching graphs, and that is known as depth first search. So at the end of this video, you should be able to describe what depth first search is, talk about some of its uses, and manually trace depth first search on a sample graph. All right, so a lot of this might sound similar to breadth first search. If you've already read about or listened to a video explaining what breadth first search is, depth first search is definitely similar, but there are a couple of key differences that we are going to explore. So just like depth first search, just like breadth first search, depth first search is an algorithm that is used to search a graph. And it can explore all the possible paths of a graph to find the one with the smallest weight. However, as it traverses your graph, it will still start at the root node or at the start node, just like breadth first search does. However, instead of traversing across one level before moving down, moving further away from the root, what we'll do in depth first search is actually just pick out one branch of our graph, one path, and trace it all the way to the very end, as far away from the root as we can get. Down, if we're traversing a tree, down all the way to those leaf nodes. If it's a different type of graph, essentially just tracing that path until we can't continue anymore. But the idea is still that we want to traverse the graph in such a way that we're only exploring nodes one time. Okay, so as you can see in this visualization of depth first search, we're still starting at the top, right, the root of our tree, but then we're going down each branch one at a time. So starting off on the left-hand side, we're starting off traversing all the way down that left branch until we get to the end. Then we're saying, okay, what's the next branch so that I can traverse all the way down to the end? And it's kind of that middle branch there before we move on to the right. So when is this a useful searching algorithm to use? We can use depth first search to find both connected and strongly connected components within larger graphs, which is also something that can be done with breadth first search. But one particularly useful application of depth first search is when you're trying to find a solution to a problem and you know there is only one solution. So if you, for example, are trying to find the solution for solving a maze and there is only one correct way to start that maze and then exit that maze, if you look for that solution using breadth first search, you're going to have to traverse every single possible path before you find a solution, right? Because remember, with breadth first search, we're not getting to the end of our paths until the very end of the search. However, with depth first search, remember you're checking one complete path and then another complete path and then another complete path. So with something like with different types of puzzle solving problems or things like that, depth first search can actually work a little bit better because you might stumble upon the solution before having to check the entire graph, which is helpful. Okay, so let's actually trace through a graph using depth first search. So the algorithm that we are going to follow, we are going to begin at the starting vertex. We're going to explore that vertex. And every time we explore a vertex, we're going to see, okay, is there an adjacent vertex that I can explore? Is there another vertex, another node on this path that I can continue down? If not, so basically if we've hit the end of this branch, the end of this path, then we'll go ahead and mark that node explored, remove it from the stack. So one key difference between breadth first search and depth first search in terms of implementation. With breadth first search, we were using queues to keep track of what nodes we had explored, what nodes we had yet to explore. However, with depth first search, we're actually going to use a stack instead of a queue. All right, so let's take a look at an example. So if our starting node in this graph is home, and we want to traverse this graph using depth first search, we'll first look at our home node and say, okay, is there an adjacent node that I can explore? And if we look, yes, the school node has not been explored yet. Okay, so I'm marking the nodes that we've already explored that are scheduled to be explored as gray. If they're unexplored, they're white. And then once we're totally done with them, we'll mark them as black to indicate that they're already explored. But anyways, going back. So starting with the home node, we see, okay, yes, school is adjacent. School has not been explored. So let's go ahead and schedule that to be explored. Okay. Now let's go ahead and explore school. So is there anything adjacent to school that we can explore? And it looks like yes, there is the work node that is adjacent to school. So what are we going to do? We're going to go ahead and add that to our stack and color that gray. Now if we look at the work node, there are no paths that lead away from the work node. So there is nowhere else to go from this particular node. So we can say that we've reached the end of a path. At that point, we want to start popping things off our stack. So remember, with a stack, we are following last in, first out, right, as we pop things off. So the last node that we added to our stack was work, so that is the first thing that's going to pop off. Now we're going to go back to school. Is there anything else adjacent to school that we need to explore? Looks like no, there is not. So we'll go ahead and pop that. Now we're back to the home node. If we look, there is still one other unexplored node from home. That is the store node. So we'll go ahead and put that on our stack, color it. Now it's time to explore store. If we look around, however, we see that, okay, there's nowhere else to go from store. There's no unexplored nodes we need to check. So we go ahead and pop that. Now we're back to home again, but this time there are no more unexplored nodes left that we can get to from home. So at this point, we can finally say, all right, our root node, our starting node, has fully been explored, and we can pop that off the stack. So remember, with depth first search, it's just another method that we can use to traverse a graph, to search a graph for a particular solution. However, we are searching down each complete branch, not across levels like we do with breadth first search. So we're exploring each branch to its deepest level as far as it will go. So this is a good algorithm to use if you know that your solution is going to be very far away from the root node. Because with breadth first search, you know that you're going to process those leaf nodes, those nodes away from the starting node, very close to the end of your search. With depth first search, you'll process some of those earlier in your search, so you could potentially come across your solution more quickly.